Hi, my name is David Hu. I'm an assistant professor of mechanical engineering and biology at Georgia Institute of Technology. My lab is interested in how animals cope with their environments while they're moving. And today we'll be looking at how very small insects fly in the rain. Imagine that you've been shrunk down to the size of your pinky nail. The world then becomes a very dangerous place. Raindrops, which originally were only a nuisance, have become the equivalent of 5 tons in weight, and they fall at a speed of 1,000 of your body lengths every second. That's incredibly heavy and fast. Although this scenario sounds like science fiction, this is in fact a daily reality for the world's smallest insects. Mosquitoes thrive in rainy and humid conditions, and they've been around for 200 million years, and in that time have evolved a variety of mechanisms to deal with such conditions like wind gusts and the rain. By studying insects, we can gain insight into the simple question of how to fly in the great outdoors. It's a difficult problem. There are wind, gust, rain, and this is especially important for technology. Recently, there's been a lot of interest in what's called the design of micro-aerial vehicles, very small flying micro-robots that can perform surveillance. These robots will also have to face the conditions that natural insects face, and by looking at how insects have adapted to that, we can design better robots. We can also start to understand how weather affects the flight patterns of what's considered the world's most dangerous animal, as mosquitoes are responsible for the spread of malaria worldwide. However, very little is known about how mosquitoes behave in different weather conditions, such as precipitation. Today, we will ask the very simple question, how can mosquitoes fly in the rain? This will require some knowledge from both biology and physics. Like any good scientist, let's start with a hypothesis. Let's see what the two opponents are. A mosquito is about a centimeter in size, about the size of your pinky nail, and it weighs a very small amount, only 1 milligram. In comparison, how big and how fast is a raindrop? What forces are involved? See if you can talk to your neighbor and talk to your teacher and write down what forces dictate the terminal velocity and size of a raindrop as it hits the ground.